yourself stuck in a rut? Feel like you're dead in the water? Need a friendly pull in the right direction? Or maybe you want to take everything with you? Towing can help. Whether it's pulling, lugging, yanking, hooking, or hoisting, being a drag was never so good. Now, towing on Modern Marvels. This is the easy part. This is the hard part. And it's not just this. It's this. And this. And even this. You may think you know towing, but there's an incredible variety to it. A whole science to it. And sure enough, a history. But a good place to start is on the side of the road, with your car inoperable, and tow truck operator Rusty Morse on his way in one of his state-of-the-art trucks.
Most of the towing done nowadays is done with the wheel lift due to the fact that it's mostly damage-free. Many of the vehicles today are too soft to be lifted up by the bumpers or the front end, so you have to pick them up by the tires so no damage can occur.
It may be nerve-wracking for a driver to watch his car being hauled away on the end of a truck, but it rarely does any damage to the vehicle.
As you can see, the L-arm cradles the tire quite nicely. No part of the vehicle is touched during the towing process. We retract the vehicle. We want to put as much weight forward as we can and still leave room enough between the vehicle and the back of our tow truck to turn safely without hitting the bar on the back of the tow truck.
This tow truck is a sturdy workhorse, capable of picking up vehicles weighing thousands of pounds. But what if you've just driven your big rig into a ditch? Operators like Rusty have that covered too, with state-of-the-art monsters that can handle anything that's roadworthy.
With the rotator boom, I have the option to work off the side of the truck as opposed to working off the back, which allows me to not have to close lanes of the freeway, especially in heavily congested areas.
Operators may need to brace their trucks with outriggers like these that stabilize their vehicles against the weight of their tow.
When I pick up heavy loads, I have to watch the chassis tilt to see if it starts to rise up. If it does, then I have to set the load back down and reposition my truck where I can extend my outriggers out a little bit.
In a way, this is how the auto towing industry began. In a ditch, nearly a century ago in 1916, in Chattanooga, Tennessee, with a man named Ernest Holmes.
Ernest Holmes Sr. was considered the grandfather of the towing and recovery industry. There was a car wreck here in Chattanooga with Tin Lizzie, and it went off into Chickamauga Creek.
It took Holmes and 10 men just to pull out the Tin Lizzie.
He said there's got to be an easier way than this to get a wreck out of the creek, and so he went back to his garage and started working on and formulating a plan to build a wrecker.
Holmes had been pondering an additional dilemma. Mechanics who had all their best tools in their shops had to leave most of them behind to brave the elements at some secluded breakdown where a stranded customer required service. To solve both problems, Holmes designed a recovery vehicle from a 1913 Cadillac auto chassis, cut off behind the driver's seat, with a tripod of poles welded to the frame to create a crane. On the poles was a winch or pulley system that provided mechanical advantage. Mechanical advantage can allow a single person to do what might normally take several people to do. For instance, a pulley might enable a single person to lift a weight 10 feet. The pulley may need 20 feet of rope for that lift, but one person alone can move it with the pulley. The formula is work equals force times distance. Everything the towing industry would later rely on proved to be on Holmes's wrecker. But the first time he took it out, the truck failed, and he had to pull the wreck out with old-fashioned manpower.
He didn't have the outriggers set on it yet. That's the device that's let down on the side to stabilize it.
Correction, almost everything was on that first truck. Holmes added the outriggers before job number 2, and the $15 billion American towing industry created in the wake of Mr. Holmes's first unsuccessful recovery has been, in a sense, a continual refinement of those original elements. Early on, Holmes seized the opportunity to sell his homemade tow trucks to repair shops and began making wreckers full-time. Though he was joined by other manufacturers, Holmes remained an innovator throughout the 20s.
Most of the time they used an old car, a heavy-duty car, like a Cadillac or a locomobile or something like that, and cut the back of it out and build a wrecker on the back of it.
The tow truck has basically evolved from an A-frame hoist on the back of a vehicle with just a block and tackle or a chain hoist, has grown into having 2 winch cables to work with, which was one of Ernest Holmes's early innovations, and made it a lot easier for recovery.
2 winch cables allow a single truck using chains to tie off to both the wreck and an anchor post, like a rock or a tree. Early towing equipment hooked into the frame or steel skeleton of the vehicle to be towed. Holmes's pivoting boom allowed tow trucks to recover vehicles from the side or at difficult angles. Towers also used a retractable cradle or ambulance that slid under a wreck and lifted part or all of it off the road. During the 30s, motorized winches powered off the truck's transmission began to overtake the hand-cranked ones.
The mechanical wreckers pulled till something either give or broke, which was usually the wire rope.
A flailing rope, one that could potentially decapitate someone, underscores another constant in the towing business. It's dangerous. Operators who weren't killed by a snapped rope were careful not to be crushed by a damaged automobile or hit by oncoming traffic. Today, towing equipment is designed to cease operating before reaching a breaking point. But back in the 20s, the growing industry coincided with explosive auto sales and the attendant rash of breakdowns, collisions, and other mishaps. Eventually, manufacturers realized that towing wasn't just a way to get wrecks back to the shop. Towing was its own industry, separate from auto repair. In light of this, they stopped cobbling trucks together from spare parts.
They started buying new trucks, which are called chassis, and they would take and order the chassis, and then they would build the wreckers to go on the back of it. So that really changed the industry.
Tow truck manufacturers now sold brand new wreckers that were specifically designed for towing. The only significant design changes were new methods for working old ideas. Although tow truck equipment remained constant, the way tow truck operators recovered vehicles underwent a major change during the 1970s. Automakers responding to the energy crisis and demands for safer passenger vehicles made lighter, more flexible cars that would be damaged by a traditional frame-hooked tow.
Newer vehicles aren't strong enough to be towed the old style. We have plastic fairings, license plates, bumper brackets that could get damaged while towing with a sling.
For instance, that sexy road-hugging design that makes a car attractive to drivers makes it problematic to tow operators.
As the clearance of automobiles keeps getting lower, we're challenged to keep designing our equipment to maintain a lower profile to still be able to get underneath it and pick it up.
Although winches and cranes and outriggers didn't change much, they were now powered by hydraulics, which are stronger and lighter than the engine-driven machinery, and which use liquid pumped into a chamber to force the extension and retraction of supports.
Modern tow trucks today are basically all hydraulic operations. You have recovery booms that will extend and raise and lower hydraulically that aid in many recovery situations.
Those modern tow trucks are put together here at Miller Industries, just outside of Chattanooga, the largest tow truck manufacturer in the business. And like all the others, it still buys chassis ready-made, then constructs a tow truck behind it.
We use standard steel, but we also use high-yield steels. We also use a lot of aluminum, and we're into stainless because weight is an issue as far as what the vehicles can carry, and also what the operator has to do as far as lifting.
Building a 70-ton tow truck with a pivoting hydraulic boom that can rotate a full 360 degrees and can lift, well, another 70-ton tow truck begins here.
I think the hardest part is the logistics of moving all the individual piece parts through the plant. We manufacture roughly around 5,000 to 6,000 vehicles in the full range from small wrecker carrier and large annually.
The 200,000 square foot plant brings in steel every day, as some 400 people work to assemble the trucks. Workers maneuver the giant parts using overhead cranes in the ceiling. Roughly a month to a month and a half later, out pops a shiny new truck.
What you're seeing right here is one of the latest innovations. It's called wireless proportional controls. Basically, this wrecker flies by wire. This allows the operator to take the passenger side controls out of the wrecker itself and operate the machine up to 500 feet away.
Signed, sealed, and delivered. A truck like this with all the bells and whistles might cost $400,000. You can order one with wireless proportional controls directly from Miller, or review the different makes and models at one of the industry's conventions. There you'll find many of the new innovations being introduced into the towing market to make life easier and safer for operators. And that's where we're going next. It's a tower's paradise at the Towing Trade Show, where all the latest gadgets get together. Towing industry founder Ernest Holmes Sr. began his career as an interior decorator at a local department store, selling curtains and drapes. Towing will return on Modern Marvels. Welcome to the Tow Times Western Regional Tow Show in Reno, Nevada.
Excuse me. Quite a few years ago.
If you're in the market for a brand new wrecker or just want to spruce up your old one with some flashy accessories, you've come to the right place.
This is one of the Cadillacs of the towing bar. This is next to indestructible. You can take this, throw it on the floor, it's not going to hurt it.
By using air cushions, you spread the load over a wide area, not causing structural deficiency to the trailer.
The purpose behind the ice slide is so it can be used as a safety device for the individual drivers as they exit the vehicle.
What's great about this truck is capable of handling a family that is maybe stranded on the road. What this truck provides is the opportunity for the tow operator to pull the car up and then also get the family comfortably in the truck.
The truck behind is a prototype. It's a show concept vehicle, crew cab based on the new 560 chassis truck. It's a aluminum bedded vehicle. It's got a fully leather upholstered interior, automatic transmission, air conditioning, CD player, all the comforts of home.
It's like Disneyland for towing professionals. A wonderland of new gizmos and improved favorites for the thousands of people who make this their business.
The industry actually has towing-specific companies of about 50,000, and that means those are companies whose primary business income is towing.
This event will draw 5,000 attendees, including a surprising mix of vendors.
Latest technology is the sliding technology, where the crane that you see behind you slides up and down the chassis of the truck, which enables you to get a lot more reach.
we deal with the regulatory environment because they're dealing with motor vehicles. Motor vehicles are regulated by states and federal government, and as a result, there's paperwork and processes that they have to go through.
Important, but not too exciting. For thrills, you can join the boys at Dynamic Manufacturing, who are playing with their rotating carrier.
It turns 180 degrees. 90 degrees one direction, 90 degrees the other. And what that is, it basically gives the opportunity to, if a person is pulling a car out of a parking lot, a person is pulling a car out of a ditch, very easy to get to that vehicle.
And if that doesn't do it for you, someone's bound to be hoisting a truck in the air. With their flashy lights and new hydraulics, towing trade shows represent the cutting edge. But the history of towing reaches all the way back into prehistory, to the first time someone pulled an object that needed moving. Adding animals such as horses and oxen to the equation really put things in motion.
The first vehicle that animals used in work was a sled. And that was with runners on the ground, and they would pull that, and that would move an object.
Eventually, sled runners were replaced by the wheel, one of the simple and revolutionary machines. Now otherwise immovable objects could be easily and efficiently moved from where they happened to be to where they needed to be. The key was hooking or harnessing the object to the animal. A device called a yoke, which originated in the 4th millennium BC, fits like an adjustable collar around the necks of oxen or cattle in front of the bony humps on their backs. The cattle push against the collar to drive the wagon or plow. Horses required a lighter device that could be strapped to their bodies because yokes tend to cut off their windpipes. Horses, like cattle, pulled the carts or wagons by pushing against a harness. This is the way all animals tow, and this towing worked quite well for thousands of years.
Before the invention of the internal combustion engine, transportation work was dependent upon the horse and upon steers for work.
Large draft horses were bred for the heaviest work, which often involved towing farm equipment. Conversely, miners used small beasts of burden, such as ponies and donkeys. For centuries, the animals have been used to tow ore out of mines. But with the invention of the steam engine, the horse was decisively moved from a place of vital importance to human technology to one of vastly diminished importance. Locomotive engines propelled trains across continents. Car engines animated the automobile. And engines propelled ships, which ultimately led to the need for another great towing vehicle, the tugboat. Next, the portable powerhouse that runs the waterways. The most famous animal towers on Earth are the Anheuser-Busch Clydesdales. At over 200 strong, they are the world's largest herd of draft horses. Towing will return on Modern Marvels. In October of 2000, 4 Yemeni harbor tugboats escorted the USS Cole out of the port of Aden. Though a tugboat escort is the norm for such large ships in harbor areas, nothing was normal about this escort. The Cole had a 40-foot square hole in its midsection, the result of a bomb planted by an Al-Qaeda terrorist cell that hobbled the ship and killed 17 sailors. The harbor tugs transferred the ship to the dry dock deck ship Blue Marlin. The billion-dollar destroyer was then brought back to the United States for repairs. But tugboats provide assistance to any ship in need, not just the Cole, not only in times of crisis. Dwarfed by their gargantuan payloads, tugboats are deceptively powerful. Tugs are essentially mobile, independent engines that push, pull, and nudge objects that can't entirely control themselves. They're usually escorting a ship much larger than they are, safely into a narrow port or berth.
From the tug's perspective, you are really at a disadvantage because all you see is a huge hull of a ship. I kind of feel sorry for the operators on the tugs because they really can't see what they're part of.
Chad McCauley, chief mate on a Crowley tugboat in Los Angeles Harbor, is off on just such a job.
This vessel here is the BT Alaska, and she's an oil tanker down from Valdez, coming into Long Beach to discharge a load. And primarily what we do is ensure that they get to dock safe. Normally it has a pilot boarding area, which is about 1.5 miles, 2 miles out. Port pilot gets aboard, and at that point he meets up with 2 of our escort tugs. The pilot communicates with those vessels, and they tether up. Our deck winch down there has a 8-inch high-tech line, and they pull up to the ship. Men on board the ship pull it aboard, attach it to the deck, and at that point we're attached and we can control the ship in case of an emergency.
Why would a 1,000-foot-long, 188,000-ton ship need help sailing into a 45-foot deep, 600-foot-wide harbor?
They're just too big, too much mass, it's confined spaces. Their ability to stop is very limited due to the fact that they're in water.
But not if Chad and his fellow tugboat operators get into formation around it. This formation, called a matrix, is based on the tonnage of the vessel and its cargo, and it determines the amount of horsepower that will be needed to bring the ship slowly and safely into berth. It also allows the tugs to stop or even back up in order to control the behemoth as it moves into harbor.
It seems like they're going really slow, but at this speed, if he hit the dock, he wouldn't stop until he went 300 feet into it.
Chad's boat alone can provide 4,800 horsepower. This modern tugboat operates with a modest 4-man crew, 2 operators and 2 deckhands, and lots of gadgetry.
Basically here we have our VHF radios for communication with other vessels and with the pilot. We have a radar, our steering system right here, which consists of these levers and wheel, and basically the controls for the winch.
Another panel reports information back to the operator about the winch.
First one here, this is line tension. This amount of tension and tonnage that we're pulling on the line. There's a meter on the winch. And scope or footage, the amount of line that we actually have out off the winch. 82 feet of line at the moment.
But the real workhorse on this tug is the omnidirectional rotary drive system that descends from the center of the hull and spins like an egg beater.
Today they can go in any direction you want. They can thrust sideways. They can do just about everything but stand on their heads.
Once the Crowley tugs have the BT Alaska safely into its berth, they'll repeat the process 5 or 6 more times in a single 12-hour shift. Roughly 6,000 tugboats and towboats serve coastal and inland U.S. waterways, helping navigate cargo along more than 11,000 miles of riverways, serving 600 ports. Add to that the cargo shipped on the Great Lakes and a domestic ocean trade. Nearly all of this trade is possible because of tug and towboats, which trace their origins over 200 years, when ships began being built to unwieldy sizes. The first boat ever built to tie onto and guide other ships was William Symington's steam-powered 10-horsepower paddleboat, Charlotte Dundas, in 1802, which made its maiden and final voyage through the Forth and Clyde Canal in Scotland. Canal owners, fearing its wake would cause erosion, took the Charlotte Dundas off the canal. But the tugboat concept proved unsinkable, and before long, waterways were filled with the small but muscular paddleboats.
It's kind of an obvious use in an era when boats were rowed or sailed or mule-drawn. By the late 50s, early 60s, they moved into propeller drive.
Working together or alone, they positioned vessels into narrow or shallow areas, pulled foundering vessels into deeper waters, or transported large barges laden with heavy burdens. Much like today, tugs of old used strong chains or tow lines to attach themselves to their vessels. And like the auto towing industry, once the basics were in place, innovation has been a product of refinement and efficiency. Take the tugboat Hercules, built in 1907 as an example.
Her engine is very typical. A triple expansion steam engine was really in its own in the late 19th and early 20th century. It was rated about 1,000 horsepower, which was very powerful for its time, and it got the most use out of this steam, which was about 180 pounds per square inch coming from the boiler. The boiler really being key in terms of having an efficient pressure to use in a triple expansion engine, which expanded the steam 3 times.
Each piston connected to the others turned a crank connected directly to the propeller shaft. No complicated gears, just a simple, efficiently low-speed prop.
The bow angles up very sharply. This is mostly for a practical reason, to gain additional freeboard, distance between the main deck and the water, to allow her to handle heavy storms and the waves in those storms. A side effect of this deck is the grace in the ship's appearance.
Smaller, more efficient diesel tugs eventually replaced the old steam tugs, beginning in the mid-20s, which reduced the size of crews. Today, single tugboats run on between 8 and 12 cylinders at 70 to 1,000 revolutions per minute. Steel hulls have replaced wooden ones. Stacks and deck houses are shorter to lower the ship's center of gravity. Towboats are like a freshwater cousin to the tugboat, used to push barges along inland waterways. Towboats are not ocean-going vehicles, but are almost exclusively used for barge transportation on inland waterways, like the Mississippi.
We typically push 15 barges, and each barge carries approximately 1,500 tons in each barge, which equates to 60 trucks or 16 rail cars. So we keep quite a few trucks off the road.
Cerradino Incorporated makes towboats just outside of Chattanooga. Not surprisingly, these towboats use cables and hydraulic winches to secure their barges. And they have an average of between 700 and 1,500 horsepower, but can be as much as 10,000 horsepower. Again, historic consistency is the rule.
The boat we're building right now, this is the 45th in the series, this switch boat you're going to see, and we haven't changed it much at all. If you see our boat somewhere, you've seen it. You'll always recognize it.
Tugboats often help less maneuverable ships get safely through tight spaces like canals. But they aren't the only towing vehicle that does that job. Next, a specially designed cog railway helps ships sail from the Atlantic Ocean to the Pacific and back again, tugging massive cargo ships through the Panama Canal. Jonathan Hulls patented his design for a steam tugboat in 1736, almost a century before the construction of the first practical tug. Towing will return on Modern Marvels. It's this pure, unadulterated thrill-seeking that brings you to the amusement park, to the lofty heights of the roller coaster. Thrill-seeking motivates you to get on, but what actually gets you up there? A good tow. You crest the highest peak, then plummet crazily down the track, swerving maniacally around hairpin turns. You've got other things to worry about at the time, but whenever you ride roller coasters like this one at Lake Winnepesaukah in Georgia, you can thank a tow chain.
In order to get the car to the top of the hill, we have to tow it by means of a 75 horsepower motor. The chain is threaded around pulleys, which provide the torque that we need to pull the cars, which can weigh between 4 or 5 tons fully loaded, up the 20-degree grade to the drop point. The
cars of a typical roller coaster, large or small, engage a chain that continuously runs underneath the first hill by means of hinged hooks, called chain dogs, that hang below the bottom of the cars. The chain is wrapped around a motorized pulley system. The dogs hook into the chain as it runs like a conveyor belt up the hill. Once the car reaches the initial peak, the chain dogs disengage from the chain, and the cars are off, hurling along the track from the momentum of that first fall. If roller coasters are one of the most exciting tow trains in action, then the train mules at the Panama Canal are one of the most unique. These powerful trains are mechanical descendants of the horses and mules that once towed ships through canals. In Panama, the canal was built with locomotives in mind. These electric locomotive mules guide large ships through the canal locks. When a ship approaches a lock, it is brought to a complete stop, then tethered to the engines that straddle the lock on either side.
You know, if they crash one of those lock gates, that canal is done until the gate is fixed.
Moving at speeds not faster than 5 miles per hour, the trains safely navigate the canal locks. The locomotives must climb 85 feet above sea level and down again over the steep grades and angles of the canal lock system as the ships pass up and down through the locks. The canal recently upgraded their 26 locomotives at a cost of roughly $2 million for each brand new engine. But these trains are special in other ways. These master towers are cog engines, and the cogs fit into a rack in the center of the railroad tracks. They're modeled on a railway nearly 150 years old, more than 2,000 miles away, and designed not to pull ships through the Panama Canal, but to push tourists up a mountain.
I was told by one of the railwaymen that a man came up at the time the Panama Canal was being built to look at this rack on this railroad, and he told him that they were thinking of using this type of rack in the locks.
This railroad is the Mount Washington Cog Railway in New Hampshire, begun in 1865 by Sylvester Marsh, and still running strong. Marsh was a successful and retired businessman who hatched an idea to build a railway to the 6,288-foot summit. The New Hampshire legislature thought Marsh was a lunatic. When he asked them for a charter to build the railroad, they laughed at him.
He was very often called Crazy Marsh. But when they discovered that he wasn't asking for any appropriation of money, but they said, Sylvester, if you want to build that railroad with your own money and waste it, you go right ahead. We'll even include an amendment so that you may continue it onto the moon.
Undaunted by the legislature's lunar insult, Marsh went to work on a rack railway, a cogged strip that would grip a giant mobile cogwheel. Whether used to push, as they are here, or to tow, as they do in the Panama Canal, these cogs are the defining feature of each railway.
Well, that cogwheel in the middle of the track, with its heavy teeth, plays into that rack, and pin by pin by tooth by pin, claws its way up the hill. Everything is on that cogwheel. It not only propels the train up the mountain, but it offers a braking surface on the way down.
Though the concept wasn't original, designing one that could climb a mountain was unprecedented. Marsh faced grades over 37%, so he needed a giant cog to grip a cogged rack. But before Marsh settled on a cog railway to take him to the summit of Mount Washington, he considered a more traditional towing option: the funicular railway, which uses cables to haul rail cars up inclines. But a chain as long as one Marsh would have needed to reach the summit would snap under its own weight, let alone the weight of cars full of people. So Marsh rejected it. But a funicular railway has been useful on shorter inclines, like Lookout Mountain, Tennessee.
Funicular means a fixed system railway. On this particular one, there's two cars, one on each end of the cable. There's two double steel cables on the incline. One of them leaves one car, comes to the top of the mountain, routes 2.5 times around the large drum, then drops back out to the other car.
A little bit like a slanted elevator, the funicular railway relies on a clever but simple balancing mechanism. Each of the two cars attached to the cable acts as a balance for the other, so that the descending car in effect tows the ascending car. Energy is needed to power the pulley, but the system only needs enough to overcome the difference in weight between the cars, in other words, the passengers, and any inherent friction in the system. The wheels act merely as a guide. Lookout Mountain attains a 72.7% grade at one point on its nearly 1 mile run, the steepest of any funicular railway. Although the Lookout Mountain funicular has been towing people since 1895, manually powered funiculars have been around for at least 600 years. They're similar to the old-fashioned handheld ski lifts, which also use cables and a pulley to tow people up mountains. And their modern counterparts include the familiar gondolas at winter mountain resorts. Funiculars, cog railways, and roller coasters stretch the concept of towing far beyond that of the body shop wrecker. They pull, push, haul, and lug to get things from one place on Earth to another. But next, what about towing things off the Earth? How about towing a rocket into space? 4% of the world's shipping fleet cannot navigate the Panama Canal. The tow trains are strong enough to pull any ship on Earth, but some vessels are too big for the 110-foot wide locks. Towing will return on Modern Marvels. Towing doesn't need to be complicated. It can be as simple as a ball mount on the back of a pickup truck and a Class 1 hitch. This method is how most people tow their mobile homes and horse trailers, motorcycle platforms, and earthly possessions. But what if you want to move your immobile home, or for that matter, a 125-year-old church? One that sits on a foundation and weighs tons.
We place wide flange steel beam perpendicular to the floor joist in the building. Then we set the hydraulic jacks under the beams and lift the house hydraulically. After the house is lifted up, the dollies that are manufactured especially for the house moving industry, we mount it on the dollies.
Redevelopment of the original site demanded the move, as parishioners decided to bring their old house of worship to their new site. Obviously, when moving a structure like a church, a large truck is necessary. Here in Simi Valley, California, master house movers filed permits for permission to move the church down the street. The street had to be measured to make sure it was wide enough. Once an acceptably wide route is picked, a time is chosen for the move. Simi Valley only allows house moving between 12 midnight and 6 a.m. Then the street is closed. The easy part is the actual towing. The hard part is getting around all the obstructions, like electrical and telephone wires.
The cost of getting overhead wires raised was greater than the cost of taking the roof off of the building and putting it back on. So the customer decided to take the roof off as opposed to getting the wires raised.
As Ted Hollinger struggles to move heaven and earth with his church moving project, a private company is using towing in an effort to move from Earth to the heavens. Welcome to the Eclipse program.
The Eclipse program is a reusable launch vehicle development program that basically employs towing as a key technology. And that basically tows behind a 4-engine transport jet a rocket-powered glider aircraft. And we do this basically to use the tow airplane as a first stage.
The second stage is launching that rocket into space from an altitude of about 20,000 feet. And why would anyone want to do that?
You can basically launch from virtually any place on the globe, and so you don't need to have a whole series of facility infrastructure and everything to support this, which is very, very expensive and adds to the cost of launches.
Further, launching after being towed to 20,000 feet avoids putting your craft through the enormous physical stress and expensive extra fuel of a vertical takeoff, where much of your energy is spent in those first violent seconds. In fact, a towed launch can save between 10 and 25% of the total energy used in a conventional vertical launch. Plus, you're that much closer to your destination when you're already up in the air. It's also more pleasant for a passenger to jet into space airplane-like than to rocket into space ballistic missile-like, because Mike Gallo doesn't want to send astronauts into space. He wants to send you there.
Once you enable the masses to experience space and participate, and you can deliver them to and from space economically, cost-effectively, of course, reliably, and routinely, those are key criteria towards enabling the growth of space.
That's right. For a 1-hour flight that includes a 15 to 30-minute interlude into the realm of astronauts, of weightlessness, 60 and 100 miles above the Earth, the Eclipse can take you to Kathmandu, or Moscow, or Hong Kong, or for a slightly longer flight, perhaps, the Moon. He says he needs just another 5 to 10 years.
We spent a couple of years looking at the dynamics and the behavioral characteristics of towing and the tow line and the bungee effect, we call it, you know, the oscillations of two aircraft operating in close proximity to each other, and actually imposes some substantial loads.
The Eclipse project will eventually use a 747 passenger plane as its tower, which is normally capable of towing a vehicle with an 850,000-pound takeoff weight. The 1 1/2 inch fiber tow rope weighs several thousand pounds itself and is about 1,000 feet long, but can pay out to over 5,000 feet. Eclipse scientists had to work within what's called a low tow configuration, in which the tow vehicle takes off first, levels at about 200 feet, then the vehicle being towed takes off and stays below the first plane's wash, or turbulent airflow. The Eclipse scientists have discovered something else during their rocket tests. It's something that seems universal across the panoply of towing. Something Ernest Holmes might have told them from the front seat of his cobbled tow truck in Chattanooga.
While the dynamics and the mathematics and the prediction models are very complex, what we really found out is the simplicity of how it works.
Towing really is just a hook and a chain, a winch and an engine, a tug and a pull. Towing seems simple when cars are being pulled out of ditches. Less so when railroads are hauling passengers up mountains or airplanes are hoisting rockets into space. So when the New Hampshire legislature joked in 1858 that Sylvester Marsh ought to build his cog railway to the moon, they had no idea Mike Gallo would someday take them up on it. Yourself stuck in a rut? Feel like you're dead in the water? Need a friendly pull in the right direction? Or maybe you want to take everything with you. Towing can help. Whether it's pulling, lugging, yanking, hooking, or hoisting, being a drag was never so good. Now, towing on Modern Marvels. This is the easy part. This is the hard part. it's not just this. It's this. And this. And even this. You may think you know towing, but there's an incredible variety to it. A whole science to it. And sure enough, a history. But a good place to start is on the side of the road, with your car inoperable, and tow truck operator Rusty Morse on his way in one of his state-of-the-art trucks.
Most of the towing done nowadays is done with the wheel lift due to the fact that it's mostly damage-free. Many of the vehicles today are too soft to be lifted up by the bumpers or the front end, so you have to pick them up by the tires so no damage can occur.
It may be nerve-wracking for a driver to watch his car being hauled away on the end of a truck, but it rarely does any damage to the vehicle.
As you can see, the L-arm cradles the tire quite nicely. No part of the vehicle is touched during the towing process. We retract the vehicle. We want to put as much weight forward as we can and still leave room enough between the vehicle and the back of our tow truck to turn safely without hitting the bar on the back of the tow truck.
This tow truck is a sturdy workhorse, capable of picking up vehicles weighing thousands of pounds. But what if you've just driven your big rig into a ditch? Operators like Rusty have that covered too, with state-of-the-art monsters that can handle anything that's roadworthy.
With the rotator boom, I have the option to work off the side of the truck as opposed to working off the back, which allows me to not have to close lanes of the freeway, especially in heavily congested areas.
Operators may need to brace their trucks with outriggers like these that stabilize their vehicles against the weight of their tow.
When I pick up heavy loads, I have to watch the chassis tilt to see if it starts to rise up. If it does, then I have to set the load back down and reposition my truck where I can extend my outriggers out a little bit.
In a way, this is how the auto towing industry began. In a ditch, nearly a century ago in 1916, in Chattanooga, Tennessee, with a man named Ernest Holmes.
Ernest Holmes Sr. was considered the grandfather of the towing and recovery industry. There was a car wreck here in Chattanooga with Tin Lizzie, and it went off into Chickamauga Creek.
It took Holmes and 10 men just to pull out the Tin Lizzie.
He said there's got to be an easier way than this to get a wreck out of the creek, and so he went back to his garage and started working on and formulating a plan to build a wrecker.
Holmes had been pondering an additional dilemma. Mechanics who had all their best tools in their shops had to leave most of them behind to brave the elements at some secluded breakdown where a stranded customer required service. To solve both problems, Holmes designed a recovery vehicle from a 1913 Cadillac auto